This tutorial reviews the Captor software program. Captor is an acronym of Computer-Aided Plotting for Time over Current Reporting. In other words, Captor is used to plot time versus current operating characteristics of equipment that provides overcurrent protection in the electrical power system. Overcurrent coordination is used to protect electrical system components, to prevent human injury, and to maintain electrical service continuity by quickly isolating electrical problems. To produce an overcurrent coordination study, the following information is required: steady state and transient load currents, minimum and maximum three-phase, line-to-ground, and arcing short-circuit currents, equipment damage curves, equipment performance curves, and the operating characteristics of the protective devices. You must also document the complete protective device specifications, including manufacturer, model number, current sensor, trip unit model, setting ranges, and continuous current ratings. Additionally, short-circuit withstand ratings, short-circuit interrupting ratings, and digital photos of existing protective devices are useful in performing overcurrent coordination studies. Overcurrent coordination studies typically consist of a one-line diagram that describes the relationship of the electrical components being studied, a time versus current plot that includes equipment damage curves and the operating characteristics of the protective devices, and a detailed setting table or report. We'll now look at an interactive demonstration of the Captor program. Using the SKM Power Tools software, the Captor coordination drawings can be created in two ways. From an existing one-line diagram in a power system model, you can simply select a group of components and use the Go to TCC option to create a new TCC drawing. A one-line diagram is automatically created from the selected components. The one-line diagram can be expanded and modified just like the larger one-line diagram in PTW. While the preferred process is to create an overall power system model and create the TCC drawings by selecting parts of the system that already exist, as we just saw, you can also create individual TCC drawings without a system model. The procedure is to create a new TCC drawing, then add components by clicking on the component icons. We first enter a design voltage, then click on the Library button to select the type of device. When you double-click on a library entry, a curve will appear with default settings from the library. The device specifications and settings can be changed by changing the frame size, sensor size, by adjusting the settings from the drop-down list boxes, or by dragging on the screen the settings. We simply repeat the process to add additional components, such as cable damage curves, transformer damage curves, generator performance curves, motor performance curves, circuit breakers, fuses, overloads, motor circuit protectors, reclosers, and relays. For example, to add a motor, I click on the motor icon, enter the rated voltage, the rated size, and the design voltage. When I click on the Save button, the motor starting curve appears. The protected device settings will be selected based on the operating and damage characteristics of the electrical equipment in the power system. When you create a new TCC drawing, the default appearance is controlled by some user-defined project options. To modify the default appearance, select the Project Options and the TCC subview. The first subview is used to define the default fill patterns and colors. In this example, the first device that appears on the TCC drawing will have the red slanted fill pattern. The second device would have a blue crosshatch fill pattern. To change the default colors, you can click on the Color button. To change the default patterns, click on the Default Pattern button. The bottom row of hatch patterns are translucent, meaning you can see through the device curves, whereas the top three rows are for solid, opaque fill patterns. The next subview is called Device Flags. It's used to define whether the long-time pickup and full load amp markers are shown on the TCC drawing and the height of the flag. It's also used to determine whether the short circuit flag is shown for each device and the height of the flag. You can also set defaults for the maximum current and time that the devices are plotted. The next subview is called Device Data Block. It's used to define whether data blocks are displayed on the TCC drawing and to define the default font size and characteristics of the data block display area. Data blocks will display the protected device setting information on the TCC drawing. The next subview is called TCC Layout. It's used to set the default current axis range, time axis range, reference voltage, and current scale. The next subview is called TCC Fault Current. It's used to set a default fault current for each new TCC drawing. For example, if you're performing a ground fault study, you may need to select the default fault current to read the initial symmetrical single line to ground fault value. You may also need to change from the traditional DAPR fault values to the ANSI or IEC study results, depending on which fault study module you're using. The fault values are used to terminate the protected device curves on the TCC drawings. The next subview is called TCC Background. It's used to set the default TCC font and the grid density, color, and style. The next subview is called TCC All Devices. It's used to set the default characteristics for the device curves, such as the pen width, label fonts, pickup labels, and whether the device settings can be changed graphically by dragging the curves. Note that these project options are used to provide defaults when a new TCC is created. Once the TCC drawing is created, you can change the properties of each individual device and TCC drawing. There are several important features in the Captor interface. The selected component is highlighted in black fill and can be selected by clicking on the name or the body of the component. It can also be selected from the TCC device list. The component names can be changed on the TCC, in the component editor, or on the one line. For example, I can change the name to breaker 123. If I save the component, the TCC is automatically updated. Each component can be displayed on any number of TCC drawings. For example, if we create a new TCC drawing, we can use Component Existing to select from all the components in the project database. The component we just added to breaker 123 can be displayed on this second TCC drawing. It's the same physical breaker in both cases. If we change a setting on this TCC drawing, it automatically updates the settings in the database and therefore on all TCC drawings. In other words, the component information is stored in the project database and only referenced on the TCCs. Device settings can therefore be updated on a TCC, in the component editor, or directly in the database through the data visualizer. Let's continue with the Captor interface. Each component can be marked as incomplete, estimated, verified, or complete. This allows you to query on the database to find all of those components that meet the criteria. For example, if I want to see all of the devices that were estimated. The Library button allows me to select a different device from the library. The Function button allows me to assign multiple functions to the same component. For example, I can click on the New button and create a new function called Ground. Now I can display the ground function or the phase function for the same physical component. To display the ground function, I can select ground and go back to the library to select the ground fault curves. Now when I switch between functions, I can show the phase or I can show the ground. The Library Notes button is used to display notes from the library stored for the specific device you've selected. The Device Notes button allows you to enter notes for each specific device. The Settings tab displays the settings for the device. You can select the frame sizes, sensor plug sizes, and adjust the settings from this screen. One important concept is that Captor plots the segments for each protected device in the order specified. For example, in this breaker, we have the long time pickup, long time delay, short time pickup, short time delay, and an instantaneous segment. These segments are listed in this order. If we wanted to remove the instantaneous segment, we can click on the Delete Segment button, and now we plot the device without the instantaneous, or as if the instantaneous was turned off. The library controls the default segments and settings, but Captor provides the flexibility to change the settings and turn off functions or segments as needed. The Data Block tab allows you to display information stored in the database. The Data Block tab displays any combination of fields for the selected component. The same information can be displayed on the TCC using the View Data Block option. There is also an icon to toggle the data block view on and off. To generate a tabular setting report for the active TCC, simply select the Run TCC Report option. This report dialog lists all of the TCC drawings in the project, but defaults to selecting only the TCC drawing that was shown. Assuming we want to report only the devices shown on the selected TCC drawing, we click the OK button. This provides a report dialog where we can turn headers and titles on and off, determine whether to show TCC notes or comments, the date and time, turn on and off protective device notes and library notes, and provide sorting options for the report. We click the OK button, which provides a default name for the report, and click Save. If the report exists, it'll ask if we want to overwrite the report. Then we can view the report by looking at Document, Report, and find the report we just created, tcc4.rpt. We open the report and it displays a list of the two devices on our TCC drawing along with the settings and information. If we want to generate a setting report that includes all of the protected devices in the project, we can either use the same Run TCC Report option and select all of the TCCs in the project, or we can open the component editor, which by default lists all of the components in the project, and run a TCC report from the component editor. Another reporting option uses a third-party reporting package called Crystal Reports. We can go to Document, Crystal Report, and choose from a variety of pre-formatted reports. We select the TCC category, low voltage breakers, static trip, and there's a variety of formats we can choose from. For example, I'll select the multifunction report. This generates a tabular report of all the protected devices that meet the criteria selected. The advantage of Crystal reports is that you can have more control over formatting. The disadvantage is that because of the formatting, you must generate a separate report for each class of protected device. Fuses separate from relays, electronic trip breakers separate from thermomagnetic breakers, etc. Crystal reports can be printed directly using the print icon or exported to a variety of formats using the export icon. Another important part of Captor is learning how to print and save the TCC drawings to document your study. To print a single TCC, you can simply click on the Print button or use Document Print. To export a TCC drawing to a saved format, you can use the Document Export function. You can select a DXF file for inclusion in AutoCAD, an enhanced meta file, or you can copy to a clipboard and paste into Microsoft Word or a presentation file. For more customized output, you can print or export the TCC drawings in predefined forms. The forms are defined through Document, Form Layout. Each form has a name or description, a page size and orientation, and defined areas. In this case, there are separate areas for the TCC, the associated one-line, and a title block. You may also want to add an area for a picture file for your company logo. For forms that include a one-line diagram area, the one-lines can be specified to display or not display data blocks. For the TCC area, you can also control whether data blocks are displayed or not displayed. You can control the grid density, the density of the labels for the grid, choose whether the grid lines are dotted or solid, choose fonts for the device in the background, and control the grid color and line density. For the title block area, you can enter text or select project and TCC fields such as TCC name, TCC notes, reference voltage, or project titles. To preview the form, use Document, Form Preview. In this case, we show the TCC drawing area, the one-line diagram area, and the title block area. To print or export TCCs using your custom format, select Document, Form Print. The output can be sent to the printer, the clipboard, or saved as an enhanced meta file. To print multiple TCCs, select the Group Print button. You can select individual TCC drawings or select Check All. Each TCC drawing and the associated one-line is listed in the form. For TCCs that don't have a one-line assigned, you can select the one-line field and click on the Select Data button to select the one-line diagram. The Group Print function saves you hours by allowing you to print all of your TCC drawings with a single click. Continuing with the Captor interface, under the Edit menu, you can select the Find in One-Line option to list all of the project one-lines that contain the selected component. Selecting any of the one-lines will open the one-line and highlight the selected component. Under the Component menu, you can add new components to the TCC, clone existing components, copy and paste data from one component to another, destroy components from the project database, remove a component from the TCC, or display existing components from the project on the TCC. Under the Settings menu, you can add measurement annotation to report the operating time clearance between two devices. In this case, there is 0.07 seconds between breaker LVP1, and breaker SWBD1. Similarly, the set measurement coordinates may be used to set the measurement annotation to a specific time or current. And the remove annotation removes the measurement annotation from the TCC. Add text block annotation can be used to write notes on the TCC. For example, we can write LVP1 is scheduled for replacement. Text blocks can be resized, repositioned, and you can change the font, add borders, and make the background transparent or opaque. Under Settings, TCC Settings, there are a variety of options associated with the appearance of the TCC. The current axis range allows you to specify the starting and ending current. The default is 0.5 amps to 10,000 amps. The time axis range default is 0.01 seconds to 1,000 seconds and can also be changed. The reference voltage allows you to plot devices from multiple voltages on a common base. For example, 1,000 amps at 480 volts is equivalent to only 115 amps at 4,160 volts. The curves from each voltage level are automatically plotted at the reference voltage for easy comparison. The current scale adjusts the current axis by multiples of 10 without having to change the axis range. The Fault Current tab allows you to automatically reference the calculated fault currents on the TCC. You can reference the maximum fault current at each bus, or the branch fault current through each protected device for a fault at one specific location. You can choose to use the calculated fault current from any of the PTW fault modules. You can also enter user-defined fault values. The Background tab allows you to change the fonts used on the TCC and the grid density, color, and line style. The All Device tab allows you to change the pen width for the curve outlines, the font for the device labels, turn on and off the pickup labels and short circuit flags, and lock the TCC so device settings can't be changed by dragging the curve. The Arc Flash tab allows you to label arcing fault current values through each protected device on the one-line diagram associated with the TCC drawing. The Notes tab allows you to enter notes and comments for each TCC drawing that can be included in the form print output and the TCC reports. The Settings, Selected Device Settings menu provides a variety of options associated with the selected device on a TCC. The Appearance tab allows you to change the default color and fill pattern for the selected device. You can also change the font for the label and turn the label on or off. The Flag tab is used to turn on and off the relay pickup markers and labels, transformer full load amp markers and labels, short circuit flags for each device, and to change the height for each flag. You can also shift any curve by a current multiple and can terminate any device curve at a specific time or current. The Data Block tab allows you to enable or disable the data block for any individual device and to change the data block font and attributes. The Selected Device Arc Flash tab allows you to display the arcing fault current through each device on the TCC for a fault at any location. You can also add user-defined flags at any current and change the starting and ending time for the flag. The Settings, Reorder TCC Device List option allows you to change the order in which the device curves are plotted on the screen. For overlapping curves, the last device in the list is plotted on the top, and the first device in the list is plotted on the bottom. In this example, the LVP1 curve will be plotted on top because it's last in the list. To reverse the order, we can double-click on each of the devices in any order. Now the SWB1 breaker will be on top. The Settings Global Changes option allows you to make global changes to the behavior or appearance of all devices on a single TCC or all TCCs in a current project. You can turn device labels on and off, lock the device settings so they can't be changed by dragging the curved segments with the mouse, turn short circuit flags and pickup labels on and off, turn cable ampacity, transformer full load amps, and generator rated amp labels on and off, and turn data blocks on and off. For example, if I want to turn off all of the device labels, I check Device Label, Change to Off, and I can apply this change to the current TCC or to all TCCs in the current project. For this TCC, the device labels have been turned off. When a TCC is generated from a one-line diagram, the TCC and one line are automatically associated. The Settings menu provides options to manually associate or disassociate a one line with a TCC. The Associate option displays a list of all existing one-line diagrams in the project. Because the Captor interface has multiple windows, you must select an active window before performing some functions. For example, to apply a data block on the one line, you must click on the one-line window to make it the active window. Think of the interface as having multiple levels where you can select a window or select a device or symbol within the window. Selecting a device or symbol within a window automatically selects the window. Another important aspect of Captor is managing the protective device library. We've already seen how to select a library entry for a protective device by simply clicking on the Library button. To manage and edit the library, we use the Document Library menu option. You can have any number of libraries. However, each project can reference only one library at a time. The default library is called ptw.lib. When new revisions are released, the ptw.lib library is updated, and the changes are also supplied in a separate library called changes.lib. To copy library entries from one library to another, you must open both libraries. I select ptw.lib. I can hold my Control key down and select a second lib and click Open. With both libraries open, I can select a device from one library, use Copy, select the same category in another device, and use Paste. Now I've transferred an entry from one library to another. The same procedure can work for multiple selections. I can hold down my Shift key and select a group of devices and use Device Copy or right-click Copy. Go to the second library in the same category, right-click or use Device Paste. The same procedure can be used to create a new library. Document, Library, PTW Library. You can use the New button to create a new library. You can then copy from your library and paste into the new library if you want to transfer a device to someone else working on a project. Projects reference library entries using the manufacturer, type, and description fields. So it's important not to change these entries. It's also important to keep these entries consistent throughout your organization. To add a new library entry or edit an existing library entry, you can use Device, Edit, or Device New. Device Edit brings up the information from the existing device, and lists tabs for the device, frame, sensor, plug, trip curves, and arc flash. The Device tab has fields for the manufacturer, type, description, maximum voltage rating, and the TCC number for the device. You can also list single-pole or multi-pole devices and add notes for the specific device. The Frame tab allows you to list a description for each frame, the rated voltage, frame size, interrupting rating, and test X over R. The Sensor tab allows you to list multiple sensor sizes for each frame size. Similarly, some breakers have multiple plug sizes that go with each sensor. The Trip Curve tab allows you to define the operational segments for the device. In this case, we have a long time pickup, a long time delay, a short time pickup, and a short time delay. Each segment has a name, a segment type, a range of settings, tolerance, whether the settings are discrete or continuous, and a description of the behavior of the segment. In this case, the long time pickup has 5 settings, and the settings are a multiple of the sensor. The second segment is a long time delay segment. The type of segment is a delay band with I squared T with opening and clearing times in seconds. It tells us that the time values are entered at 6 times the sensor of the device. It has 3 settings, minimum, intermediate, and maximum. And the slope of the I squared T in this case is minus 2.02. The time settings are discrete, so when I'm on the screen I can only select between these 3 settings. The library has several different segment types and also function specifications. The Captor library includes categories for low voltage breakers, motor and generator protection, fuses, relays, medium voltage breakers, and reclosers. While each category has unique capabilities, the general concepts are the same. For example, relays include a pickup segment, which is typically a function of the CT ratio or primary current, and time delay curves, which can be a series of points or equations. The size and flexibility of the Captor library is one of the key features that sets Captor apart. While the standard library contains most of the new and legacy devices you'll run into, it's nice to know that you can easily make your own additions and modifications if necessary. In summary, for a coordination study, build a model of your power system by sketching a one-line diagram, entering data for the cables, transformers, motors, generators, and protective devices. Reference each protective device with a Captor library. Select the components on the one line that you'd like to see on your coordination drawing. Use the Go-To TCC drawing to create a new TCC. You can then modify the simplified one-line diagram adjust the TCC labels, TCC layout, reference voltage, and device settings, generate a TCC report, then use Document Print, Export, or Form Print to output the TCC. This concludes the Captor tutorial. For additional information, contact SKM Systems Analysis Inc. toll-free at 800-232-6789. Visit our website at www.skm.com or send us an email to sales@skm.com.